So yeah, thank you, Vojta, for Czech lessons. Now I'll give you English lessons with a bit of Scottish flavor as well. So I apologize for that. Unfortunately, I lived there for 9 years and there's nothing I can do about that. Actually, I do have a question. How many people have anything to do with machine learning, let's say, whether that's uni or work? So we do actually have two people that I discussed it with. Okay. Now, who has heard of GPT, ChatGPT? And that's everyone. All right. How about random forests? Two people. Those doing machine learning. Okay, that makes sense. So now I think kind of the talk of the title of the talk is maybe a bit misleading because I think I'll actually try to prove the point that we can apply machine learning and different forms of machine learning in IDs. And that's not just about code generation with GPTs, but actually there are so many other things that we can do. So that goes into the question, like, is machine learning just for code completion and code generation? It's absolutely isn't. So before I start, it's a cool thing to look at this graph that we have actually collected data for professional Java developers, from which actually, if you look at the smallest chunk there, the orange, 5%, that goes for writing code. So actually, even if we invest all of our money into ChatGPT and things like that, it's only 5% where developers are actually coding. Rest of the time, they are either understanding code to know what to write, or doing other code-related activities, and these are things like debugging, let's say. 50% go outside of coding. These are things like meetings and stuff. So in IDs, there's no machine learning that can help with that, but outside, maybe. So where can machine learning actually help developers? First of all, if you look at the chunk where we had understanding code, we can look at projects that we have for code as documentation. First, I would like to present to you is similarity grouping and find usages. So who knows about find usages in IntelliJ? Okay, nice. A fair bit of you. So before, what we actually had, I hope it's visible from the back, but for versions prior to 2022.3, if you were looking for usages of any particular method, you would just be presented of this beautiful list, where you would see some categories, let's say, like, right, you have delegate to super method or functional call, but actually most of the results here are unclassified. So now if you want to actually see those examples to understand how to use this particular method, you would have to go through each single class and see those one or two results. But with machine learning, what we can actually do is cluster those usages. And now, instead of having those 352 results all unclassified and just show them separately, with clustering, what we can do is actually look at the usages, compare similarity of those, and just group them together. So we still have unclassified results, but right now they're grouped. So actually, if you have first bit of code, there are 77 similar usages. So there's no longer need to go through them separately to understand the usage. Following on code as documentation, and it's a bit of both code as documentation and also a tool that allows you to write code. We have a plugin named Polaris. Unfortunately, it is for internal users only, but we are actively working on it, and I'm hoping that soon we will be able to ship it. There are a couple of things that Polaris can do. First of all, it can allow you to find code snippets used by others, because most of the time, especially working on huge projects, it's likely that you'll be just repeating the code snippet that already exists somewhere else in the project. So let's say you're creating a pop-up window with some titles. So it's very likely that you just kind of reuse the same code. It can also help you find parameters that you need and autocomplete frequent patterns, like if you're playing with input events, let's say. So that was kind of a smooth transition to writing code. Now, for that, we do have a full line code completion plugin, which supports Python, JavaScript, and TypeScript. It's an entirely local model. which will become important in a few slides when we talk about it. It is still under development, but you can actually play with it right now. We do have a project in development for automated edit prediction, which should also speed up development process, because like if you change one parameter name, then you'll have a suggestion to change it in other places as well. It's relatively new project, so I wouldn't be hoping to have it released anytime soon, because there are still some things that need to be polished, pun intended. But hopefully we will find the best algorithm and the best kind of way to compare the similarity, so we can ship it with our IDEs soon. Now let's move on to search. And actually search, I'm super excited to present, because on Search Everywhere I actually worked as an intern. Who knows about Search Everywhere? Double shift in idea. More people. Okay. There are a couple of things that we're doing in search. So first of all, we do have fuzzy search, because trying to come up with or trying to remember a method name is very painful, to say the least, right? So actually with fuzzy search, which uses Elasticsearch underneath, it's quite easy to just describe what you want the method to do, and based on that, it will try to find the method in your code base. Unfortunately, again, for this plugin, it's still in development, so just stay tuned. But I talked about my internship a bit, and actually what we have on this, we have seen huge boost of performance in with our users, is machine learning ranking in Search Everywhere. So what this does is, on the left you see ranking without machine learning. There are some basic rules, but mostly it's just alphabetical, right? So there is a popular action I use in IDEA, which is rebase for Git. And if I just start typing in actions rebase, it's somewhere down the list. I have to either type more characters to get to it, or just keep on pressing down button until I get it. But as I mentioned, it's a popular action, so we can actually consider this as one of the features and train a machine learning model on it. And now with machine learning model, because it's a popular action, it already appears as the third result. And actually rebuild project is also very popular rebuild resources as well. So you no longer have to type as many characters or scroll down the list so far. This is actually enabled by default already in all IDEs. In actions, files, and classes tabs. We are all working on other tabs as well. All tab, I think, is the popular one, but it also presents the biggest amount of challenges. So we have to be careful what we're doing there. But I'm hoping that soon we will find a way to boost the productivity, but at the same time not break user expectations and user behavior. So we had actually a nice demo by Voit about GPT models. So what about them? Now, I'm not going to present how they generate code, because I think everyone played with that, so you know the capabilities. But actually, where GPT models, I think, kind of how we can benefit from them is by asking them things regarding documentation of certain features in IDEA. For example, how do I see diagram of superclasses in IntelliJ? If gives me very nice description. Sometimes the description is even better than documentation for some of these features. So yeah, maybe we should actually learn from that as well, and update our documentations based on ChatGPT, something like that. I've got no idea. Unfortunately, I cannot present any projects that we are working on, because using large language models and GPTs is still a very recent thing. So as much as we want to also join this hype, we do have to consider where we can apply large language models and what we can do with them, especially when they have some limitations. One of those, because what GPTs are and large language models, they basically predict the next word. which means that the output of the model may be plausible because all you're doing is just calculating probability that the next word will be correct, but it may be completely incorrect. So this is the example that we actually have seen in the previous presentation where the ball did not move. But I asked about best frameworks for combining Python and Kotlin. And according to ChatGPT, there exists Kotlin Python interop. And it's a library that provides the best way to use both Python and Kotlin. Try Googling that. There is not such library. This is because you would have maybe some other language where actually based on that probability, it's likely that a similar library exists, but this one doesn't. So yeah, there is a solution to this, and that's to verify the suggestion with exact tools. Basically check if actually the output that the model produces actually exists for certain cases, or for example, does the code compile? There is a second limitation, and that's by default, models have no knowledge about recent events. If you actually go on ChatGPT website, they will say that past 2021, if I remember correctly, the model output may be a bit iffy because it doesn't know these events. The way the models are trained, they are trained based on a snapshot of data collected from the internet at some period of time. And if anything happened after that, it's not in the data, so the model will not know about it. There are certain models which are capable of that. For example, Bing now integrated GPTs, and they are actually capable of searching for new information. So that is a possibility as well to have this retrieval mechanism. Third, models can actually use unknown dependencies, functions, or APIs. If you often ask a model how to, I don't know, parse an XML in Kotlin, it may give you code with, for example, that it expects that some function named, let's say, parse XML will exist, but it actually doesn't. So that's something we also have to be careful with. Luckily for us, because we would integrate the machine learning models with IDEs, that integration can at least partially solve this. We can look at the dependencies that are in the project, what functions are available, and based on that, give this as an input to the model and tell it, or either give it as an input, or we could also filter the results based on that. There is also a thing, and that's kind of related, that models have limited context and they don't see the whole project. If you ask it to do one thing, then it may produce some output, but it will not know, for example, that you already have a utility class somewhere else which does that thing. So the solution is in research, and that would be basically to collect better context with IDEs and research ways to integrate project data. So we talked about machine learning, but there is also a very important thing to mention about machine learning, and I think that's the two people from the audience doing machine learning will know that. For machine learning, what you need is data. If you don't have data, you cannot do anything with machine learning. But working with machine learning and in IDEs, there is also a problem with privacy. And that's especially when you're paying for an IDE and you may not be happy to also kind of pay with your data as well. For instance, the data we use for machine learning purposes, and these are like data for example, training ranking model for search everywhere, we only log that during our early access program. The rest of the time, we do not collect that data. This is because our early access program kind of, it's a win-win situation from our perspective, because you test the product, you provide us the data, and you also get a bit of an insight kind of to what's happening with the new versions. and it's completely for free. You don't need to have a paid license or anything like that to access the EAP versions of our products. There is a second thing that we cannot log anything that can be used to identify a specific user, company, or project. This is why, for example, in the machine learning and search everywhere project, we do not log search queries. We can log features about search queries, like are they all uppercase, are they all lowercase, camel case, length, and things like that. But search query cannot be logged. But even internally, we do have this fuzzy search, which works on the cloud. So that data is passed, the search query is actually passed. We still require explicit feedback for logging that sensitive data. And now there was a lot of discussion with our data privacy officer, and this is what we agreed for. But now, kind of, if we wanted to move this and actually present the feature to external users, it may be difficult to do. So to restate the question that was the title of the talk, why do we need machine learning in IDEs? Because actually, by introducing these machine learning features, we can shift things in this graph a bit. I think if we help users to quicker find the code snippet they're looking for, quicker find usages, understanding of the code may, for example, decrease, and they will have more time for writing code. Or there is also another option that they will have more time for important business meetings. I mean, sorry, that was the wrong picture. So I think in general, even if we're not talking about just writing code, the benefit of having machine learning helping you to search, find usages is a huge productivity boost. Now, does anybody have any questions?